Okay, so I want us to start today with a little thought experiment. This is something that in math, I say this statement all the time, but people in higher grades have no idea where it comes from. So I'm going to stress something that's a little odd that you're going to think, I don't know why that's such a big deal. But hopefully you'll understand what it's about as we work through this. So let's say that I told you I've got two numbers. I'm not telling you what either one of them are. One of them is the number X. One of them is the number Y. You don't have to write this down. Just think about this. This is not part of the lesson. I'm multiplying two things. One of them is X. One of them is Y. I tell you, you can multiply these numbers together and you get an answer of 12. Yeah. Do you know what X and Y are? 2 and 6. 4 and 3. Or 4 and 3. Or 12 and 1. Or 24 and a half. Yeah. Or -6 and -2. Or -4 and -3.
12,
So my question is, if I give you this information only, do you know what X and Y are? No. It can be this, or this, or this, or this, or this. Okay? Well, what if, instead of that information, what if I told you that I can multiply X and Y together? I don't know what's happening, guys. My pad is losing its mind. What if I told you I multiplied X and Y together and I get an answer of 1? Do you know what X and Y are?
1.
It could be 1 times 1. Or 0.5 times 2.
-1 times -1.
Or -1 times -1.
-0.5 times 2.
Or -1/4 and 4. So do you know what these are? Multiplying to be 1. There's an unlimited list of numbers I could come up with. Do you know what one of the numbers is? Like, can you tell me you know one of the numbers has to be something?
No. No.
You can't. Okay? Because I can multiply a whole bunch of things together to get 1. All right? Now, think about this. What if I told you I multiplied X and Y together and I got this very grand result? Say that the thing that I got was 0. What if I multiplied X and Y together to get 0? Do you know what I multiplied together to be 0?
1 times 0.
Could be 1 times 0.
2 times 0.
2 times 0.
1,000 times 0.
0 times 0.
1,000 times 0.
1,000 times 0.
45. Any integer times
Yeah.
0.
Like every single number.
So do you know what one of these numbers has to be?
0.
At least one of the numbers has to be 0. If I'm going to multiply a bunch of things together and get an answer of 0, at least one number in there has to be 0. Do you follow that logic? Do you see where that thought comes from? That brings me to, I've never used this before, but I've used their definition before. They're calling it the zero product property. That says, for all real numbers, A and B, if you multiply A and B together and get an answer of 0, then either A is 0 or B is 0. One of them has to be a 0. If I multiply two things together to get 0, one of them needs to be a 0. Zero product property. You follow that thought process, that logic? Everybody's on board. Here, This is the factored form of a polynomial. What does it mean it's factored form? This is two parentheses that are being multiplied by each other. I'm multiplying x minus 9 times 5x plus 2. I know when I multiply these together, what do I get as my answer?
0.
So what can I say? Not x equals 0.
Y equals 0.
What am I multiplying together?
The two polynomials.
I'm multiplying
X minus.
x minus 9 times 5x plus 2. So
One of those could be 0.
this whole thing has to be 0, or this whole thing has to be 0.
One of them has to be 0.
One of them has to be 0. Either x minus 9 is 0, or 5x plus 2 is 0. Follow the same thought process as before. So what we can do to find the solution is we can set each one of these factors equal to 0. Either the first parenthesis is 0, or the second parenthesis is 0. Because when I multiply them together, I get 0. So one of those has to be 0.
Follow.
And now you have two equations that you've created that we can solve to find what x has to be. So here, if x minus 9 equals 0, you can add 9 to both sides. And that tells me x equals 9. Here, what would I do to get x by itself? Subtract 2. So 5x equals negative 2. Divide by 5. So x is negative 2/5. So one of these two things must be true. Either the x value is 9, or the x value is negative 2/5. Which one is it? You don't know. They both are valid solutions.
What does this have to do with
You notice what word I just said? They're solutions, valid solutions. What's a solution?
a 0?
It's a 0. It's an x-intercept. It's a root. These are the x-intercepts of this.
So that's
Polynomial.
algebraically.
Yes, we are finding x-intercepts algebraically today.
I think that's easier than graphing.
Well, if it's factored, it is.
Yeah.
This has already been factored. Everybody sees what's happening. Point 0.5, yeah. 0.5 is fine.
Don't do that.
Okay, so this is kind of odd, and when I went and looked at your guys' homework that you had to do on Wednesday, when I wasn't here, you had a couple of them that were set up like this. You see how this is a quadratic? But what's wrong with this quadratic? it doesn't say it equals 0,
Dang.
right? It's all jumbled up. Where you've got the constant term over here, you've got some things going on over here. Now, I'm hoping you're all copying this down correctly.
Yep.
Now, let me show you an error that people make. Let me show you, and maybe you can think why this isn't going to work. A lot of people will say, oh, I know what we can do. Let's factor this.
That has to be to the same power.
Let's say factor this. What's the first thing you look for when you factor? Is there a GCF?
Uno. But that's not.
There is a GCF. There's a GCF of x. If I factor an x out, I'm left with x. If I factor an x out, I'm left with 9. Do you see how the left side, do not write this down. You guys are not writing this down, are you? Stop writing this down. Don't write this down. This is an error. This is a mistake.
Stop.
X times x plus 9. Can I do anything with this?
No.
This is factored form. So can I set this equal to -20 and this equal to -20?
No.
No, because if I multiply two things together to get -20, I have no idea what these are. This isn't -20. It could be, but I don't know that. The only thing I can do is if it's factored and it's equal to 0. That's why I went through that whole thought experiment earlier. If it said it equals 0, then I know at least one of the two things has to be 0. That'll work.
But only the hard ones.
So what we need to do on this problem, we need to make it say equals 0. So I need to add 20 to both sides. If I add 20, it will then say it equals 0.
Austin, if you don't quit working ahead of me, because I hear you doing it to yourself.
So I add 20, add 20. On the right side, -20 plus 20 is 0. Now what about if I add 20 here?
Okay. You just add to the problem.
Correct. It does not have any like terms. It has nothing that it can combine with.
It
So-
would be a squared plus, it'd be 8x squared bx plus c.
It's in the form of ax
Equal-
squared
equal to
plus
zero.
bx plus c. But now it says it equals 0.
Yeah.
So this goes back to what we were doing on Monday.
Why did you write plus 20?
That adds to the problem.
Because I added 20 to both sides. That's what I did. I moved the -20 over. It became positive 20. Added 20.
Okay.
Got it?
Is everybody okay?
Yes.
So I know this whole thing, I'm looking for where this thing is 0. So where is this equal to 0? Well, this is what we did on Monday. On Monday, you would put this in your calculator and you would find the x-intercepts. Right? We graphed it. Just put this in our graphing calculator. No longer. We're going to find it algebraically without the graphing calculator.
I hope it's fun.
Wouldn't it be like 2x's then? Because you can't combine those.
So we would want to solve it.
Yeah.
Right? Get x by itself. The problem is you can't get x by itself because there are
Those.
two x's. There are multiple x's to different powers that won't combine.
Yeah.
So I can't get x by itself, so I'm going to use the 0 product property. If I can factor this, I can make it be two things that are multiplied together to equal 0. Well, if two things multiply to be 0, I know at least one of them has to be 0. That's the process. So we're going to take the left side of our parabola, our ax squared plus bx plus c, our quadratic, and factor it. So how do I factor this? Number 1, is there a GCF?
No.
No. Is this a special case, a difference of squares? No. Is this in the form of ax squared plus bx plus c? Yes. You're going to do a times c. 1 times 20 is 20.
Wait. Are we writing this down now?
Yeah, I mean, this is the right way. What we're doing now is correct.
Okay.
I was just showing you the error people might make earlier. What are the factors of 20? 1 times 20, 2 times 10, 4 times 5.
I forgot about that. Completely forgot. Yeah, but now I remember. So refresh.
So which of these can I rewrite the b term as? 5 and 4. So this is x squared plus 5x plus 4x plus 20 equals 0.
Yeah, still 0. Still 0. I remember parentheses.
That's what's coming next. I've got 4 terms. So I need to group the first 2 together and the last 2 together. The GCF of the first parenthesis is x. That leaves me with x plus 5 when I factor an x out. The GCF here is 4. That's going to leave me with. Do the parentheses match? Yes. This factors to be what's in front of the parentheses times the matching parenthesis. Now, this is the problem you just were doing. I've got 2 things multiplied together to be 0. Either the first thing is 0 or the second thing is 0. So set them both equal to 0. So x plus 4 could be 0. Or x plus 5 could be 0. I'm going to solve those. This would be x equals negative 4. This would be x equals negative 5. Hopefully you guys see how I did that. I was running out of room. Subtract 4 on the first one from both sides. Subtract 5 from the second one.
I hate factoring.
So what does this mean?
I love it.
The x-intercepts of the parabola are at negative 4 and negative 5. Those are the solutions. You have found the x-intercepts algebraically.
Algebra.
So are we gonna have to do it in like the other ways? Or
This is the main way. We were just giving you an overview of what you were doing, what you were finding by putting it in your graphing calculator. This will be what I grade you on.
What, the last step?
all of it?
Oh.
I know you could find the x-intercepts by putting this in your graphing calculator. I've got to grade you on factoring to find them. So it's on paper, and you have to show it.
That's what I was good at.
Well, good. I'm just giving you a heads up. Before I can start factoring, I need to make it say it equals 0. Does this say it equals 0? Yes. So I have no reason to move anything. This is in the correct form. Everything is on one side, and 0's on the other. So I'm good to go. So to factor this, number 1, is there a GCF? No. Number 2, is this a difference of squares? No. Is it in the form of ax squared plus bx plus c? Yes. So you will do the a times c method. 1 times 64 is 64. So now what multiplies to be 64 but combines to be 16?
8 times 8.
It is going to be 8 times 8. We could go through the whole list. I'm trying to save us a little bit of time. Right? You do 1 times 64, 2 times 32, so on. So I can rewrite 16 as 8 and 8. So this is x squared plus 8x plus 8x plus 64 equals 0. Now when I have 4 terms, I'm going to group. Group the first 2, group the last 2. If I group the first 2, the GCF is x. That leaves me with x plus 8. The GCF of the last two is 8. That leaves me with x plus 8 equals 0. Do my parentheses match? Yes. So this factors to be what's in front of the parentheses, x plus 8, times the matching parenthesis, x plus 8. So from here, you've got options. Is everybody good to this point? Any questions getting to here?
No.
Okay. I have got options, like I said. The first, you could just leave this like it is, and you could say, two things multiply together to give me 0. That means either the first one is 0 or the second one is 0. They are the same. It is a special case. It has two x-intercepts, and those x-intercepts are the same. So where did we have the case where we had only one x-intercept? When the vertex was the x-intercept. That's what the case is here. You might could see it better if you rewrote this. This is why I talked about you had options. What is x plus 8 times x plus 8? What's another way we can write that? X plus 8 squared. Well, if you write it like this, what form is this in? This is vertex form. A times x minus h squared plus k. That's vertex form because it has something in parentheses being squared. So this means I did what with my graph? I shifted it left 8. So my vertex is at negative 8, 0, which is where the x-intercept is. Because the x-intercept's on the vertex. It all
makes sense.
It all works together. That's the cool thing about math.
The thing is, I wasn't paying attention, but at least got the answer.
That's good. All right. Perfect. Okay.
If I was a teacher, I'd hate you.
I zoned out. My bad.
Okay. What's the deal with B?
It's not equal to 0.
It doesn't say it equals 0.
So you gotta.
So I need to get everything on one side of the equation, make it say it equals 0. So I'm going to subtract 64. And so now I have x squared minus 12x minus 64 equals 0. Is everybody good with that step? Now you have a quadratic equals 0. Well, I can't get x by itself because those won't combine. So I've got to factor. That's the only other option I have. Factor that. So I would do the a times c method. Again, I got 64. What multiplies to be 64 but combines to be negative 12?
16 and 4.
So 16 times 4.
Negative 16 and 4.
And you're right, it's going to be a negative 16 and a positive 4 because we need it to combine to be negative 12x. You guys are... I don't know how to help some people. I just don't...
Some people can't be helped. Just like you.
And I'm trying, but you're testing my patience. I'm going to group. What's the GCF of the first one? X, which leaves me with x minus 16 in parentheses. The GCF here is a positive 4. That leaves me with x minus 16. Do the parentheses match? So what's in front of the parentheses? X plus 4 times the matching parenthesis. Everybody with me to this point? Two things multiply to give me 0. That means either the first parenthesis is 0 or the second one is 0. You hear I'm saying that? That's always my wording. I say it just like that every time. Subtract 4, add 16. So the x-intercepts are at negative 4 and 16. Those are the solutions. So now I want to graph this quadratic by hand. No graphing calculator. So what all things could I know about this from the get-go? I could know, does it open up or down? How do you know it opens up?
Because it's positive.
Well, don't say it. What is it?
The 8.
The A is positive. A is positive, it opens up. Okay, I've got that information. What else do I know about this? Has it been stretched or compressed?
It's, I don't know.
It's not been stretched or compressed because
Oh, yeah.
the A term is 1.
Oh my gosh, I just realized I messed up.
Do you know the y-intercept?
Yeah, maybe.
What's the y-intercept? Where does it cross the y-axis? At negative 8. The y-intercept is always the C term. It's at 0, negative 8. Can I find the vertex?
You can.
I can. How?
The two A, B thing.
By first finding the axis of symmetry. We find the axis of symmetry by using the formula x equals negative b over 2a. Here that would be
Negative 2.
negative 2. So it's 2 over 2 times 1. So the axis of symmetry is 2 over 2, which is 1. Is everybody good there? Because I know where the axis of symmetry is, I can find the vertex. I plug 1 in for x and find the y value. So I plug 1 in.
What's 1 squared?
It's 1.
It's 2x. What's 2 times 1?
1 squared minus 2 times 1 minus 8. That's 1 minus 2 minus 8. That is negative 9. So the vertex is at 1, negative 9. Right, that's all review stuff. You're adding one more thing to it. Find the x-intercepts. Where does it cross the x-axis? Well, how can I find the x-intercepts? I need to factor this and set it equal to 0. Because where do the x-intercepts happen? When the y value is 0. Remember that whole big spiel I gave on Monday? So we'll set the y value, which is f of x, equal to 0. And then we're going to try to solve this. Well, I've got x's to different powers, so I can't combine them, so I have to factor. This is in the form of ax squared plus bx plus c, which means I'm going to do a times c, which is 8. What multiplies to be 8? 1 and 8, 2 and 4. I need them to combine to be negative 2.
2, 4 minus 2.
It's going to be a negative 4 and a positive 2 because it has to combine to be negative 2x. So this is x squared minus 4x plus 2x minus 8. And I'm going to group. GCF of the first parenthesis is x. That leaves me with x minus 4. GCF of the second parenthesis is 2. That leaves me with x minus 4. This factors to be what's in front of the parentheses times the matching parenthesis. Now I have two things multiplied to be 0. That means either the first parenthesis is 0 or the second parenthesis is 0. When I solve, that means x equals negative 2 or x equals 4. That means the x-intercepts are at negative 2 and at 4.
But why do we need to know all this?
Because now I can graph it by hand.
You have everything in place for you now.
That's the only thing we didn't know before is how to find the x-intercepts. Now we do.
Is it weird that like everything that you do to find the x-intercept is just reversed of like the number? Like
What?
x minus 4 equals 0 is just 4. Because it's just you should do the opposite.
Because I had to set it equal to 0.
Yeah.
And if you think about it, well,
He doesn't want to do it.
so let's graph this. So let's pull a graph up and let's graph all these key characteristics. So come on, work for me. It's not going to work. Give me just a second. Work. Please work. That one didn't work either. There we go, that one did. Okay. So because my vertex is so far down, I'm going to put my x-axis up here at the top. Okay, so I'm shifting my graph a little bit. So this will be my, I'm going to put my x-axis here. Oh, come on. So there's my x-axis. Now let me draw my y-axis. Now let's put all this information I know on the graph. I know it crosses the y-axis at -8. 1, 2, 3, 4, 5, 6, 7, 8. Means I'm going to be right here. I've got a vertex at 1, -9, which would be here. The axis of symmetry is at x equals 1. Because of the axis of symmetry, I know I have another point here. Right, that's all the information we've known so far. But now I need to add my x-intercepts. So I have an x-intercept at -2. And I have an x-intercept at 4. And so now I can get a better scale for what this is going to do. All right, you guys can go.
As you so much wisdom.